Let's go to page 247. And this section is about fractional equations. The objective of this lesson is to solve and use fractional equations. So let's go to example 1. Example 1 says solve 3 over x squared minus 7x plus 10 plus, okay, so I'm going to put 2 over 1 equal to x minus 4 over x minus 5. So this is an example of the fractional equation. It's an equation with fractions. Okay, so first we need to do is we need to factor this. Okay, so you go off to the side. Okay, you need to add to get negative 7. You need to multiply to get 10. So you need to start with negative 1, negative 10, negative 2, comma, negative 5. And so this would be a correct combination. So when you factor these using the master product, the step 4, you're going to get x minus 2, x minus 5. Okay, once you factor, your next step is go and multiply by LCD. Okay? But before we do that, let's go ahead and find the restrict value. So over here, x cannot equal to 2 and cannot equal to 5. Those are your restricted value. And your LCD is going to be equal to x minus 2, x minus 5. But you need to have both of these. Okay, so go and multiply by LCD. So this will cancel out, so you get 3. Now when you multiply all this together, remember where this came from? This came from this, right? So when you multiply, that way you can save your time by just multiply these, right? So you're going to get 2x squared minus 14x plus 20. And this will equal to, this will cancel out. So when you multiply these, you will get x squared, and you add to get a middle term, and you multiply to get a last term. Okay? And then from here, so let's go ahead and move things over to this side. So let's go and minus x squared on both sides. So this will cancel out. Plus 6x, plus 6x. So this will cancel out. Minus 8, so this will cancel out. So over here, the square term, you're going to get x squared. And the linear term is going to give you minus 8x. And this will give me 20 minus 8 is 12, plus 3 will become plus 15. Okay? Then once you equal to 0, you have to do the factoring. So again, you have to add to get a negative 8. You have to multiply to get 15. So you start with negative 1, comma, negative 15. Negative 2 cannot, so negative 3, comma, negative 5. Okay. And from here, you're going to get x minus 3, x minus 5. And when you solve, you're going to get x equal to 3, x equal to 5. But remember your restrict value, x cannot equal to 2 or 5, so this answer is no good. And so the only answer you get is the x equal to 3. Okay, let's go to example 2. Okay, example 2, you have a pool over here, and you have a small pump, it's pumping out the water, and the time, it doesn't tell you, so the time it would take, you don't know, so you just call it T. And you have a larger pump, the time it would take would be 7 hours less than that, so time for the bigger pump would be 7 less than, so you have to go backwards, so it would be 7 hours less than the smaller pump. Okay? So the rate would be the reciprocal. So rate would be equal to 1 over t. So for example, if it takes 10 hours to pump out, then the rate would be 1 over 10 because 1 hour so it will pump out 1/10 every hour. So that's why when you have the time, you take the reciprocal to get a rate. Okay? So over here the rate will equal to 1 over t minus 7. Okay, so now we're ready to write the equation. Okay, so together, or not yet, so together, the time will equal to 12 hours. So the rate together will equal to 1 over 12. So again, together it will take 12 hours to pump out the pool. So that means every hour, the rate, every hour it will pump out 1/12 of the water. Okay, so you can take reciprocal. Okay, so now let's go and write the equation. So for the large pump, every hour it will pump out t minus 7, and it's going to pump for 12 hours. Plus a smaller pump, every hour it will be 1 over t, again times by 12 hours, and this will equal to pump out the water of one pool. Okay, so now let's go and write it in the fractional form, so easier to visualize. So you got 12 over t minus 7 plus 12 over t equal to 1 over 1. So now to solve the fractional equation, okay, you need to multiply by LCD. But before we do that, let's go and look at restrict value. So t cannot equal to 7 and t cannot equal to 0. Okay, and your LCD will be just t, so LCD will equal to t times t minus 7. So multiply every term by the LCD. So this will cancel out, so you get 12t. This cancel out, so you get plus 12t minus 84 equal to t squared minus 7t. My next step is the t squared is on this side, so I'm going to just flip, swap sides. So I'm going to get t squared minus 7t equal to 12t plus 12t minus 84. I'm just flip it over. Okay. Next, I'm going to move everything to this side to make it equal to 0 so I can do factoring. So I'm going to minus 24t by 12 and 12 is 24. So I need to minus 24t, so this will cancel out. And I need to plus 84, so this will cancel out. Okay, so I end up with t squared minus 31t plus 84 equal to 0. Okay, so from here I can do the factoring. I need to add to get negative 31. I need to multiply to get 84. So start with negative 1 comma negative 84, and negative 2, negative 42, negative 3, negative 28, and that's the one. So I'm going to get t minus 3, t minus 28. So from here I get t equal to 3 and t equal to 28. But t equal to 3 is no good because remember the time for the large pump is t minus 7. So if you put a 3 in here, you're going to get negative 4. Okay, so you can have a negative 4 hours, right? Okay, so t equal to 28. This is for the small pump, and t minus 7 is the large pump. So minus 7, so you get t equal to 21 hours. This would be the large pump. And this is the one that it asks you to find, right? So it would be 21 hours. Yeah, let's go to the next example. Okay, example 3. So it's an airplane flying. Okay, so you break into two halves. So the entire trip is the distance equal to 2,000 kilometers. So you can read the poem and get all the information. And the speed or the rate you want the average to be 720 kilometers per hour. So that's what you want to get. So the first half, the distance equal to 1,000 kilometers. Well, if the total is 2,000, so one half is 1,000, and the second half is also 1,000. Okay. And the rate for the first half is 600 kilometers per hour. And so you want to figure out the rate at the second half. So this is the first half. I'm going to put 1 as a, and so 1 means first half, 2 means second half. So that's what you're looking for. Okay, so for the motion problem, you have r times time equal to distance. So to find the rate, we need to find the time first. So from here, we can find the time over here. So the time total, the time, I'm going to put capital T for total time, will equal to, so time, so here, if you divide by r, so time equal to distance divided by the rate. Okay, so time would be equal to 2,000 divided by 720. So the time would be equal to, you can simplify that, so it would be 25/9 hours. Okay, so that's the total time. Then the time over here, so T1, so time for the first half is equal to D1 divided by the R1, right, using this formula. So T1 equal to 5/3 hours. Okay. So over here we can find T1 equal to 5/3 hours. And now we can find this time over here because the total time is 25/9 and T1 is over here. So T2, so T2 will equal to the total time minus T1. Right? So total time minus that will give you this time. So T2 will equal to 25/9 minus 5/3. So T2 will equal to 10/3. 10/9. 10/9 hours. Okay, so once we find the time over here equal to 10/9, then we can find the rate, okay, using this formula over here. So R times time, so R2 times time 10/9 equal to the distance of 1,000. Okay. So you need to break down into small bits and do each part. Okay, to solve this, we need to multiply by 9/10. So multiply by 9/10. So this will cancel out. So R2 will equal to 900 kilometers per hour.